Alright, here we go. I've changed some settings on my microphone. See how well it goes. Space. What layer am I on? I'm on the number layer. Space. So backspace, space. 30. Space, backspace, 40. Close braces. Ampersand. Ampersand. X. Vect. X. X. Plus 5. Close 4. Int X. Vect. Cute. X. Mohit Kumar. Hey, what's up? Hey, man. You're the first to join. Thank you for joining. Oh, man. I messed up, wait. Here we go, okay. 0. That was more hard than I expected. Tilde. C. Image. X. Big X. Alright, void move int 2x int 2y private void init image info. Okay. Just gonna see how good that audio is for a second. Give me a sec. I just checked that audio seems alright, I think. I basically reduced the sensitivity but increased the volume. Regardless, the point of today, or tonight I should say, is to work a little more on some study, and then maybe if we get the time we can do some Leetcode and one lesson of the Odin Project, hopefully. I still gotta have dinner though. Biodecay, hello. Thanks for joining. You're the second person to join. Found your channel because I'm learning the Odin Project. Oh yeah, nice. And am Australian, nice. Nice. Also learning at night, huh? Right now? Maybe? Maybe not? I'm partially learning through the Odin Project. Only learning what I need to know for what's necessary for my app that I'm building. But I'm doing it. Anyway, let's do some study now. Yeah, I have you open in Linux right now. I've been relearning how to type. Using all fingers because I used to type 140 word per minute using like 5 fingers. I'm guessing they're like the index, the thumb, maybe. The index and the middle fingers, maybe, most likely. Alright, yeah, nice. But 140 word per minute using 5 fingers is something else. Imagine what you can do with 10. 280 word per minute, let's go. Am I not right? Just had to type in my password. Because I play games a lot, I'm used to typing keys with my left hand. What do you play? The what's that one where you like use your mouse a lot and then you tap like really fast? Osu, I think. Anyway, I should let you study. Well, thanks, man. I'm planning ahead to uni in a year, so I was just planning to do some Odin Project before going and brushing up on my math. Yeah, good. That's good. It sounds like you're in high school still then. You know, doing that stuff now would be good for you in the future. I applaud. You'll definitely be ahead of me when you get to my age, I reckon. Given that I'm assuming 4 years older, if you're 18. tomorrow's gonna be Friday. Okay, CS. Before I do that. Oh, this isn't even updated. Hold on. Dude, I looked at my Uni CS course. I counted 28 books they have and found most of them online. Good. You know where to search, right? I won't say it, but you know where to search. Sounds like. Alright. Why is nothing updating for a second? We're just gonna close it and reopen my Obsidian. You just type PDF at the end of the book you want. Oh, yeah. Basically, right? I suppose it is just that easy. I was thinking of slightly something else, but I'm sure you know as well, right? Surely, wink wink. libgen. What? Euler's phi function. Okay, that makes sense. Where was my... Oh no. I have Obsidian installed but stopped using it till recently because I made it too complicated. Yeah. I think I just made it pretty complicated myself. I have a problem now though. I think the notes that I wrote disappeared. Damn. Just trying to think how I could even recover them. If even possible. Darn, I should never have renamed this right now. I think that caused the biggest issues for me. Yeah, I just set myself back a bit. It's pretty bad. This pretty much a day's worth of writing gone down. Let's see. Maybe it's in my Git history. It's not even close. Alright, fine. It'll just mean I have to push this information, or else I'm going to lose it next time. At least I largely remember most of it, and I'll just rewrite it. Unfortunately. Gotta close and reopen. Newen, I'll just call you Newen. How old are you? I'm 21 right now. Turning 22. How important do you think Leetcode is? I would say if you want to get into big tech, it's pretty important. Otherwise, don't even worry about it. I'm doing it because, yeah, I want to get into big tech. It's really sad that it's this way, but I guess you can also think of it as, you know, you're not just learning Leetcode to get into a job, but you're also learning it to practice your DSA, you know? So you want to do well on the interviews, yeah, basically. It's basically that. Yikes, okay. I'm gonna have to have a look at because this is on my other computer. The other computer's stuff disappeared and it's so sad. Let me think. I had 0 backups, did I? Unless where's my time machine? Damn, last backup was yesterday. It still contains most of what I want, right? Have a look. Yeah, I think I'll be able to find some of it in the backups, so maybe it won't be all doom and gloom. BFS. No, that's still not it. Maybe I need to go back. Ooh, why is this kind of sad? It's not even allowing me to go back further. What's up with Time Machine then, if you can't even go back further? Zahai-san. Bro, did you watch the tutorials I told you? Not yet. I don't have time. Not yet do I have time. And Nguyen, where are you from? I'm from Vietnam. Well, I'm from Australia. I'm Australian born. I know this, I put on silent study, but I haven't even started silent studying yet. I gotta figure this out though. time machine backups. Okay, I'll give it some time to load, possibly. Just gotta wait a little bit. Yep. It's coming alive. It's just taking time to load. Do I know Vietnam? I mean, I know of Vietnam. I haven't been to Vietnam. If that's what you're asking. Still loading. This is what my screen looks like right now. Oh, I think that loaded. Thank God for backups, to be honest. It's like the hardest way to get your backups back, but I'm still hoping it works. Let me see. Yeah, I got some stuff on there. Good. Oh my God. Can't believe it, man. Alright, I restored some of it. Okay, you can see it pop up now. This is what I had up until this point, and then like this morning, I mean just now I had to write a bit and it wasn't being committed at all. What's that keyboard? I saw an ex-Netflix guy called the Primogen use it. I mean, if you're following the Primogen, he's my inspiration too. This keyboard is called the Glove 80. And if you look in the description, I provide links to it specifically. I'm not affiliated or anything, I just own one. Just want to share it as well. But yeah, it's all black, blank POM keycaps, MCC POM keycaps, with red linear switches. I think. I know it is. Okay, alright, I have most of the information that I did write down, which is all here now. You know, basically it was all of this, starting from, yeah, it was basically all of this. This was all the stuff that I wrote. Now restored, thankfully. But still bad because now I've got to rewrite some parts of it. For example, you have tutorials here. I have to rewrite part of this. Page 4. Oh, thanks for the sub, whoever that was. Let me have a look. Yumaruchi, thanks for the sub, man. Hamza Rashid, what exactly are you doing? Right now I'm just trying to figure out how to get most of my data back, but I'm actually just rewriting some of it now. Because I did get most of my data back. But this is for a subject called AI Planning for Autonomy. And it's just an AI subject I'm learning right now. And Nguyen says, are you still learning or do you have a job? I'm still learning most of my time, but during my, I guess, bachelor's, I already had a job as well. So I was working kind of like casually as well as studying full time. And then I basically dropped that now. I've kind of honed in on what I want to do. And the job that I had was still related to code, but it was still taking up a lot of my time, and I wanted to focus more on study, I guess. I know. So it was page 4, I believe. That's correct. So state model of state model from tutorial 1. Yeah. And then can be written in, and this is like all the, oh man, this actually took some time to write as well, but oh well. I'll just try and rewrite it from memory then, just to practice. P is equal to something. Which is the S0, I'm going to say. What's your typing speed? It's better than this usually, but I haven't typed in a while actually. I'm kidding. I have typed recently. I would say, so typing words, that's like 80 words per minute on this keyboard. Typing code is more like, varies between 20 to 40. 40 being the max. And yeah, like right now I'm just typing, so you can see how that goes. My god. Sometimes, I'm hitting buttons just trying to see which one's the right one. Okay, so S0, there was S and SG, S underscore G. Biodecay. I seen those code language packs on Monkey Type are pretty good. Yeah, right? They are. I personally think so too. Because I used to go on Speed Typer. That was like another one. But it was, a lot less, I guess, functional. It was less functional over, like, you can tell over time that this website was just less featureful than Monkey Type has. So yeah, Monkey Type just has better overall, but I was using Speed Typer only because I didn't know that you could actually change the language of this. Hamza Rashid said, I think you're struggling with Vimotions. Yeah, man, I'm still learning, to be honest, so it's something I'm still doing. And given that, sometimes I'm just typing like this, I'm not using Vimotions at all because it's just all characters. So I don't get to practice it enough, yet at least. And sometimes I just default to a few Vimotions and then I don't consider other options. So that's something I also gotta think about as well. 0 0.5 f y equals number I long close bracket ampersand y I, oh my god, 0x 5f 3759 df 1 y equals minus x 2 y y return y. See, 23 words per minute. Accuracy is okay, you know, I reckon. Still could be better, but you know, let me go to English. Okay. 82 words per minute, accuracy 97. See? It's alright. Doesn't matter as long as you do like 10 minutes a day, you'll be 10x better when the year ends. That's it. That's it. That's the long-term way of thinking, right? So it's good. I also like to, you know, think about it like that as well. You know, practice over time, it'll be fine. But yeah, I'm pretty happy with that, you know. That's like when I'm honed in. Let me just keep it to code. You know, Python code actually is easier to type in general. Oh, I say that. And I make mistakes. Still. Yeah, that's right. What BioDecay said. I'm gonna just be studying, except I've been procrastinating a bit now. I gotta rewrite this. I mean, technically, you can count this as coding. I'm just coding up a markdown file. SG. What else was there? There was an action. There was a transition function, set of transition functions. And then there was a cost function. So I think these are all, I think. Damn it. I'm using the wrong key bindings. S_0 goes here probably. Fuck. I'm just getting them wrong. Need to type more. Alright, I think that's it. Given that, from the tutorial 1, now let me zoom in on this. So, state is equal to S1, S2, S3, S4. Oh wow, okay. What am I doing wrong? Might just be this. Yep, and S0 is S1, I suppose. The goal state is it's a set of states. So S is equal to S4. And so this is S goal underscore capital G action action of a particular node is equal to is going to be bracketed S1 to S2 and S1 to S3. Now let me double check that. So I'm gonna have to look a little better at this page. So SG S. So okay, so it is just S0 after S. It is just this AFC. And action of S1 is S1 to S1 3, yep. Or it's also going to be so AS4 is just going to be equal to empty set, and that'll be good, I think. Fuck, there's dinner now. I'm gonna eat dinner. Etc. We'll also have F for the transition function. So I'm just write F SA is equal to S prime e.g. F S. So S being the state, let's say S1 to with the action of S1 to S2 will give you S2. And that's it. And C S1 S2. The cost of S1 and S2 is equal to 1. Okay. Alright, I'm gonna get some dinner now. So as an so that's only an example. I'm gonna have to say etc. And yeah, there's more here that I have to read through, and I'll be good. Okay, be right back. Okay, I'm gonna eat first. Got some dumplings. I realized that light text only covered study. I mean, it covered the silent, so it might have been hard to read. Anyway, whatever. taking a break. Dinner, yeah. Let me just change it to something dark. Alright, taking a break. Be right back. In about 30 minutes, probably. Yo. Sabota Walnuts. Oh yeah, Sabota Walnuts. Hello, hello. Sorry, I just came back from the wind throwing out my stream again. Yeah, the internet cut out again. Sorry about that. We should be fine now though. I'm also back from dinner actually, so let me just remove that tag. Although let me also. What else? Probably just gotta quickly wash up and I'll come back. At most like 3 minutes. I'll be back again. By the way, when you're doing silent study, does it mean you focus on work and not reading chat? Can we still hear you work on stuff? That's a good question. Valid questions. I would say I haven't really done silent study. I've only done it once before, basically. And that's actually a choice that I have to make, whether to just go silent completely, keep my mic on every now and then maybe, and also not sure if I should even be reading chat. If I want to be focused, I might not read chat, but if I'm like a little less focused, I will read chat. But I think maybe I'll try to read chat to a minimum, because I need to get some stuff done by the end of tonight, I reckon. There's a lecture that I gotta watch. When I'm watching a lecture, for sure, I won't be reading chat. But yeah, you might hear me speak. You might hear the stream of the lecture, that is. But yeah. Let's see, what else am I missing? I think that's what was the main gist of that, but I gotta continue to read through this. I don't know, I feel like hearing your thoughts about what you're learning would be pretty good to watch. Like what you're doing, what you get from the stuff, and your learning, etc. I think that would be good in general, yeah. I mean, if you think that's helpful, I was worried it'd be a bit annoying, to be honest, but I mean, if it's helpful, I'll take your word for it and I'll speak more about it. I think that would make sense. Yeah, alright, I'll take that advice to heart, you know? Like, I'll actually start speaking about it a little more. I mean, not that I don't already, but I have some sort of validation to continue speaking about it. It's also good for me to, you know, make sure I know what I'm reading as well. Keep me on the edge. Alright, well then, let's do it here. Wait, hold on. Okay, problem 2. State versus search. State accumulated cost ID of parent. Yep, so I wanted to make sure I knew exactly what a search node consists of. And that was the thing that I wanted to add. Yeah, I got up to where I wanted to add that I've lost the nodes from. So what consists, what what's inside a search node? What's inside a search node? The search node has 3 values. The state, accumulated cost, and cost of accumulated cost GN, and ID of parent node. So those are the three things that I'll write, and then I gotta make a link to it. So tutorial 1. Inside this we have page 7, page 6, page 6. Man, I'm just hitting the keys. Okay. So that's good. So FIFO queues are what breadth first search is made of. First in, first out is just a queue. And okay, whoa, there's a lot of text. I don't really care about you reading chat or not. Alright, that's good. Teach us what you're learning. Yeah, use the Feynman technique on us. Lol. I'm just learning this shit too, but I'm probably a year away from doing the essay. If I was going to rely on the education route. I see. I think I'll just do Bachelor of IT though, because like I naturally gravitate more towards sysadmins, DevOps type stuff. Yeah. Fair enough. Like I feel like the same, to be honest. But yeah, I'm doing Masters of IT, specializing in AI anyway. We'll see how it goes. Anyway. Alright, yeah, let me focus. You guys like chat, and I might just dart my eyes every now and then, but maybe I won't focus too much on chat then. Okay. Breadth first search, depth first search. Depth first search is going to be a LIFO, but let's try and run through this problem. So, you know, there's markings here, level 1, level 2, left to right. Sure, it doesn't really matter. Node expansion, order. From, I think what this part going backwards is just backtracking the actual route that you take. So it looks to me, so ID of parent node is 2. ID of parent node is 0. So you know from that, it goes from S1, S3 to S7, which is going down all the way there for breadth first search. That's fine. Depth first search is similar, but it's LIFO, so it's a stack. And from the stack, it'll just go, you know, if you pick all the left side, then it'll just go to 7 here. And that's all good. Iterative deepening search. Let's see, what else could I understand beyond what I already studied yesterday? It closes, you put N0 into your closed node and you have nothing in the stack. Does that make sense? Yeah, because you're limiting to the 0th position. When you do that, you're only doing this first node. And so in the open stack, you only have that first node. And you pop it off the stack, process the node. You find that S1 is not a goal state, so you don't worry about it. And you have no open stack. You have nothing in the open stack. In the open set. And then the closed set just has N0. So that's limit of 0. Now, the limit of 1 means you go to the first depth or one level deeper than the previous of 0, and you would include 2, 3, and 4. And that's pretty simple. You just now do depth first search. So because it's iterative deepening, deepening, I suppose, is where that depth first, I guess that's what's making us, I guess that's what's pushing us towards using depth first search. I don't know how to explain that properly. Iterative deepening search is just depth first search with depth limit. Yes. But we continue until we have nothing in the stack left. And then all we're left with is these 4 nodes in the closed set. But that's not it. Then you go to level 2, and then you would find this point, just like following the same structure. But you notice that unlike before, you don't end when there's nothing in the stack anymore, but you end because you found the goal state. That's good. Okay, that's all fine though. What's the actual optimal solution? Now, the actual optimal solution is 1, 4, 6, 7, because the costs of each of these lines is less than every other cost to the solution from the start position. So you got 1, 1, 4, that's 6, and then this one's 12, and this one's 7. So yeah, explain under which conditions the algorithm guarantees optimality. The condition that it guarantees optimality is when each of these lines have an equal cost. So breadth first search and ID will be optimal if the costs are equal, such as all costs are 1. Can any of the previous algorithms be adapted to account for Gn in order to make it optimal? Can any of the previous algorithms be adapted to account for Gn in order to make it optimal? That's a good question. I don't even know. So Dijkstra, apparently, expanding the node with the lowest accumulated cost instead of the lowest depth. In order to make it optimal. Yeah, so that is Dijkstra's algorithm. Expanding the node with the lowest accumulated cost instead of the lowest depth. It really does come pretty easy to know Dijkstra's algorithm once you know, I suppose, iterative deepening search, breadth first search, and depth first search. And also the concept of Gn, where Gn is equal to, if I'm not mistaken, F plus C, where C is the cost. F is like the previous node cost, possibly, we'll see. Okay, problem 3, describe a simple example of traveling salesman problem, along with its corresponding state space model. So a simple example of traveling salesman problem along with the corresponding state space model. So again, that's the state space model is, I call it the state model here, but I'll call it state space. So definition should be brief, clear, and compact. Compact means using mathematical notation to define sets, i.e. S is an element. The S is equal to x, given x is an element of V. To define that there are many states, an element is in a set V. And pseudocode, i.e. to define the transition function. What? This is going to be quite a bit, right? Okay. So state space S, state space model, right? Okay, initial state S0 is an element of S. Set of goal states SG is a subset of the state space. Applicable action function for each state, S is an element of the state space. Transition function F, SA of S is an element of S, and A is an element of the actions. And then the cost. Alright, so note for the TSP, a city can be visited more than once. I don't know what TSP means here in this context. A traveling salesman problem. Note for the traveling salesman problem, a city can be visited more than once. You can start at any city. The goal state is to visit all cities, and no need to go back to the starting city. So your set of goal states is pretty obvious when you read this. It's just a matter of how to represent it. So the set of goals is going to equal to the set of all the nodes in any order, it doesn't matter. Because it's just a set, I reckon. Okay, so hint given, V, a set of cities, V start, A, starting city location, is the set of edges if there is an edge between two cities, and V prime is a set of cities that have been visited. Okay. So let's try to understand this then, because I believe this will be the answer. But, and this is all mathematical notation, supposedly. You use these angle brackets, but we haven't really discussed what these angle brackets mean. I'm guessing they are just what defines S0. And they're just like a node, as opposed to a state only. Okay. I suppose, you know, your state is actually just okay, so you can think of the state possibly as just, it's a state. And in this state, apparently we have like a tuple-like representation. So this is a representation just like anything else, where you have this time not only the position where you start, but also the set of positions that you've been to, which makes sense. So the initial state is then just all the places you've been to and your start position. And your goal position would be V. And it doesn't matter what your current position is, but if you have visited all nodes, all locations, then you're good. So that capital V is, let's see, a set of cities. So that V is a set of cities, which is all the cities in this case. Given that V current, that's the position, current position, is also in the set of cities. That's all good. So the state now is, the state S is the set of V and V prime given V is in V and V prime is a subset or equal to V. Now the thing is, like, I guess, you know, when you think about this, everything that you see here, you know, you're describing all the different states that are possible. So you'd have to enumerate through all of this. And that would be any permutation. Not only permutation, but any smaller permutation. I don't know what you'd call that. But there would be a lot, basically. But okay, that makes sense. Action A. We're given the current position and your V prime. Your current V next given V current V next is an element of E, where E is a set of edges specifying if there is an edge between two cities, vertex 1 and vertex 2. Okay, V current V next. That's an edge. So the action for any V when you're at current is from the current to the next position, given that the current to the next position is an element of the edges. Alright, that makes sense. Damn. Slow, but we're getting there. Alright, transition function F. You're given the node or the current state and one of the edges. You know the next node, so V next and V prime or V next. Fair enough. That makes sense also. Damn, this is like actually, it's just like another abstraction layer to the problem of representing the state space model, just like what I did here. It's just another layer to your understanding. It's just a deeper, you know, a deeper data structure in a sense. And then the cost of V current V next is equal to the cost of the current and the next simply. That's just simple. You're just saying the cost is just you define what cost is, the meaning of the actual thing. Okay, that's fine. So blind search. We looked at this finally. We've gone through it. Let me see what chat's like. At least you're not a prompt engineer. I like you explaining it. At least you're not a prompt engineer, fair enough. I like you explain it's better than when it's just silent. Yeah, okay. That's good then. I'm playing Factorio whilst I watch someone study DSA. What a nerd. Yeah, I mean... We're all nerds here. No shame in that. There is no shame in it. Not here. Alright. Blind search done. I had another list of I had a list of stuff to do here, so let me just reference that. So yeah, okay, I did that now. Now I'm gonna watch lecture 2. Yeah, I'm gonna watch a lecture. So CS. Now the question is, should I also just make the audio listenable and not mute my desktop audio so you guys can hear also the lecture? Probably, right? So this is a CS lecture. Not computer science, but cryptography and security, by the way. Yeah, man, I love a bit of lecture. Alright. Let's see then. I'm gonna have to put on headphones. Let me think about this. I technically don't even need to watch this lecture. I mean, to make it to tomorrow at least. But it's better that I do it now. And then after this hour of lecture, I'm gonna be able to do two workshops, which is like just Python files, Jupyter notebooks. Let's see. So, what are good notes to take? I guess just in general, how would you take notes? Why would you take certain notes? Okay, so the thing is, for me, I've been trying to yeah, I mean, if you look at my notes currently, right now they're really messy, but I'm going to make it slimmer. My main pieces of content that I really want to keep is these. This is the important part that I want to keep. Because they're questions. They're questions that I can ask myself, and if I don't know the answer to, they're toggleable, so you can hide them first. But if I don't know the answer to it, I can see the answer. And sometimes I'd also put, I should also just always put a link to where I got that information from a lecture slide or whatnot. So it's always there that I can always reference back to. Find a note-taking model you can okay, right, yep. Outliner, Zettelkasten, daily note, first para, right. I guess yeah, there's a lot of ways as well. Pick a framework and then work it out, yeah. I think, yeah, for me right now I'm using Zettelkasten, but I don't really have a very, I guess, correct Zettelkasten. I'm pretty sure there's no such thing as a correct Zettelkasten, but what I'm writing right now is pretty much questions for a particular subject, one subject. So one page has a full subject of all the content. I think that's just makes more structural sense for me. I guess when you lack structure in a Zettelkasten, that's what I do. Yeah, make it minimal friction as possible. I actually found that I've been lacking in a minimal friction alternative, although you've told me, well, was it you that told me about the app? I think it was. You told me about the quick note-taking app. Extension for Obsidian. Yeah, I still haven't looked into that, but I think that'll be a good thing to look into. Anyway, alright. Notes. Start writing. Start listening. Sorry, I'm playing around with the dial. You can kind of hear myself speak, which is kind of weird.
This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Classical ciphers. Let me also open up a page on the side. Okay.
Oh, okay, now it's active, okay. So let's continue with where we left yesterday. And yesterday I mentioned to you about simple Caesar cipher. Is everything clear about Caesar cipher?
A Caesar cipher.
Yes or no? And then you have affine cipher, where, so in some sense, I can give you very quickly how does that work, basically.
So firstly, a Caesar cipher is a cipher which shifts the letters left or right by a certain key value or key amount. And there's only 26 possible key amounts or key values. So you can brute force it 26 times to figure out the solution. Now he's talking about the affine or affine cipher.
Sorry.
Look at the number of students in class right now. Not too many, I will say.
Okay. So, as I mentioned to you, all the encryption one, you can have a plain text, and then you can have encryption function using a key, and that will become C.
Encryption function with a key.
Right? That's the idea. Okay, first
to get a cipher.
Imagine about all these functions. What does it do? What are its arguments, etc. So what here in all the classical cipher, where does P belongs to? Here because we already talked about concrete numbers, so it is 26. So which means that you can map A to 0, B to 1, C to 2, and so forth up to Z to 25, and then you get everything modulo 26. So Caesar cipher in that case, the encryption function in this case is simply P plus some K. Okay, now K is of course a number from 0, 1 to 25, and you get C here. Now what is the decryption function? So if you have with the same key, what you do is C minus K, and in this case, you know, it's P
Sure.
plus K minus K mod 26, you get back P. So, okay. So where the things are clear, we don't specify whether it is a, you know, it's a plain text is from English alphabet or Z26. We interchangeably use the initial mapping is assumed. Okay.
So what is the definition of cipher? What is cryptology? A parent of. Just going to quickly answer this question. So that's cryptography and cryptanalysis. Yes, all right. Kirchhoff's principle. Man, I got to look back at these questions, but all right. The thing that I want to write. Let's see. So what is the encryption and decryption functions for Caesar cipher? And I can say that the encryption using a key of some plain text is equal to C. But this C here, when using the Caesar cipher, is equal to the plain text plus the key. And let me have a think. It's plus the key mod a certain value. Well, 26, because there's 26 letters in the alphabet. So I would assume that's correct. And so the decryption, which is D, I'll have to write D underscore K of C is equal to P, which is equal to C minus C minus K, probably still mod 26. Yes, I would assume that still makes sense. I do have a bit of a blocked nose, so I'm sorry if I start breathing heavily. Yeah, so decryption is C minus K, and we know that C is equal to P plus K. So P mod 26 is just P.
So you probably, this is the kind of thing, and the, you know, with affine.
Oh man, if there's only a way to link a specific
cipher that yesterday I discussed.
Heat map sources. If only there was a way to link to a specific slide. In the lecture, I would put it here at 4:30. I'll say 4:20. And just rename it CI in bracket lecture. What is this lecture? It's technically the 4th lecture. I won't remember it very well if I do it that way. Week 2, lecture 2, I reckon. Week 2, lecture 2. Week 2, lecture 2 at 4:20. I'm sure it's also in this part of the textbook actually. Control F. Caesar. I'm sure he'll talk about, wait. It's right here, so let me also copy this page. So page 21. I actually hate linking, it takes too much time. So it goes to Veen when I want it in, yeah, so that's wrong, 20. Okay.
It is, you have A and B, 2 parameters, and that is K is A equal to A and B, and P now is A times P plus B. So from this, we already discussed about modulo. All this thing is modulo 26. So if something, some number has been converted into from P to A, P times B, how do you get back? So, if this is C, then you can say the decryption function with the same key A, B, and C is, so now what you do, first you have to, you can see that is C minus B, and then you have to divide it by A. I'm just telling. Yeah. Okay. You see, so I'm writing it in the way where whatever that goes into a typical student who coming here this subject from experience, I would write like this, right? C minus A mod 26. So this is precisely actually what you're doing is A inverse into C minus B. So because you see, the C is AP minus B. So when you subtract B, you get AP, and you get A inverse, you get back P. And that's what is the inverse. Okay? Is that clear? So here, so basically what happens is 1 over A is actually A inverse, mod 26, but you shouldn't think in terms of the real numbers. And that's the kind of typical problems that I see. So if you really work through 26 now, you will understand which are the, can have all possible A's for which you can have a key. For example, if A happened to be 2, because modulo 26, A inverse doesn't exist, and hence that will not a proper map. So whereas when I look for this cipher here, that the Caesar cipher, any element K can be a key, but for affine cipher, not all AB. So for example, if I take AB, how many elements are there? A can go to 0, 1, 2 up to 26. B can go to 0, 1 up to 26. Basically, there are about 26 squared different elements. 26 squared different elements, right? A 0, 1, 2, 3, A, B. But not all A's, B, of course, you can have any number, but not all A's you can have, because only those A's which have inverses. So when you take mod 26, look at 26 now. It has two prime numbers, 13 and 2. When I try to find inverse of a number less than 26, you already have a GCD function to you can try, and you find out you can't have inverses for 2, 4, 6, 8, 10, 12, 14, and so on up to all the even numbers. And also you can't have things for 13, and 26 is of course 0, 26. So if you actually you can exclude all of this, only those numbers that are odd numbers that times 26, and of course you can't allow 0, 0, so you can actually compute their typical keys. This is what those of you who come to yesterday or understood the inverse modulo thing. From there you can easily conclude that the number of keys available in affine cipher is not 26 squared, but is much less than that. Precisely how much it is, you do all those calculations and discuss in the class, and then we'll come to know. Okay, so let's continue with our.
I didn't know what Bro was yapping
this
about
was a
there,
kind of a, so did we do the rail fence? No, we'll just do the Caesar cipher, and then we went to the affine cipher. So how many different keys? This is what I discussed.
Hold on. Zoom into window. Zoom into Chrome tab in Windows. Per tab zoom. I need like natural zoom though. However they do it in MacBooks. Win++. Windows magnifier. Oh my god, what a pain. How do I even unmagnify? Oh well, that doesn't work, so I'm gonna close this. You're back.
Now in this one, okay? So what is the complexity of the brute force search? So that also tells you if you know how many different keys, then you know the complexity of a brute force search for a fine cipher, right? I mean, you have been given some cipher text, and you keep on trying A, B with all these values. So how many are there? Can somebody tell me how many keys are there? Yeah? 12 times 26 minus 1. You can do, but you can see that kind of a thing. So you go in the next week workshop, and there you discuss about these issues, okay? And we will generalize few other these ciphers, for the purpose of understanding in the subject. Now let's look at a general monoalphabetic cipher. Monoalphabetic cipher. Yeah, how does that look like? Okay. Now this is, when you have a monoalphabetic cipher, what does it mean? Because I have now A up to Z, all the number. You can map A to any one another and B to any other like that, right? So that's kind of a, you look at a general key. See, in the previous case, Caesar cipher and a fine cipher, I'm going to assign each prime text a number, and then I'm going to modify this number by a function. Now, Caesar function is very simple, simply shifting a number, and affine cipher is just multiplying another number and shifting that number. But in general, if you allow any possible permutation, so if I have A to B up to Z, what I can do? How many different, each permutation is a key, right? I can make A to Z, some B to something else like that. But then the question is, in this case, what is the structure of a general monoalphabetic cipher? If with that, how many different keys are possible in such case? Can you think of? See, here I'm not limiting myself. So look, there is also, even with this simple idea, there is like how plain texts are modeled, how we actually treating for the encryption, like how we are modeling this one. So here, I don't care, I have all the Z numbers, and a monoalphabetic cipher, let's say you may have a large cipher text, but what do you do? Every time a particular alphabet goes to another alphabet. That's what a monoalphabetic cipher is. In the whole cipher text, if a particular number comes from, it comes from a previous fixed value. So how many different, so when I allow such generality, that I have A to Z, and A can go to anything else, B can go to, of course, if A goes to some, let us say, a T, then B cannot go to T. So, but from T, it can go to any other number. Yeah?
So you're translating one letter to another letter?
Yeah, another letter, and I assign this permutation arbitrarily, right? Yeah, that's what I'm saying. That's what the answer. I got 26 factor. So really, in a general monoalphabetic cipher, there are 26 factor keys. So now, if you have such a thing, your key is just a mapping that is taking A to B to some other number. So the key is just basically simply a mapping like this. Each key is A A, B, C, D up to Z. A can go to T, B can go to G, like that. This particular thing is a key, right? When in a cipher text you have a Melbourne, you go wherever M is there. Let's say it go to Z, then E is go to say some H, then L goes to T. So you actually basically using this key transform a plain text. This is a plain text to a cipher text, right? This idea is clear. So there are exactly, so A can map to any another. There are 26 possibilities here. After A gets mapped to T, you only available 25. B can go to out of 25 choices. So you can see that the last one. So if you actually
Give me a sec, I just gotta call someone real quick. Right, I'm back.
the total number of keys is multiplication of all of this is just 26 factorial. Okay, so look at, I mean, if you're interested in about this kind of classical ciphers, there are plenty of them. There is also one famous cipher called Vatsyayana cipher. You know, you know what's Vatsyayana? This is a famous person who wrote Kama Sutra. This person, he has a cipher in his name, and there what is that? In this case, if A goes to T, T goes to A. So you have a condition that A goes to another number, the same number actually mapped back into this. So T goes to A, for example, T is there, then you go. So with that condition, how many different keys are possible? You can take an exercise and do. You know, I can probably give some of those things as exercise to fun kind of thing. So, but let's say 26 factorial is a 26 factorial is a formidable number. It's a very big number, right? But if I go to in a brute force search, it's quite impossible, right? But do you think this cipher is safe? So no. Why? Here, because the language statistics comes into picture. Because remember, what might happen is
language statistics language, frequencies.
Say, for example, which is the most occurring alphabet? E. You know, E, because you know, so the E, then he. So E is it's a pure vowel, right? It gets matched into other vowels. So obviously E, frequency of E is fixed. So you look at any English language.
Let me just quickly check chat here. Alexander Petronov. I think your GitHub is what every software engineer strives for, haha. Man, it is, I don't think I deserve that praise, but Thanks, man. Appreciate it. And also Biodecay and Sibodai also left. What did they say? Do you go in person to class or online only? Damn, I wish I could answer that. I mean, you are coming back to watch this, so I do both, basically. Do I go in person? Yeah, I've been trying to go back in person more often actually now. I actually am only looking at this lecture right now because it also clashes with a different lecture that I went to on the same day. So I'm just catching up on it now. Sabodai says, I do online only, but if I go to Vic Uni, I will go to class for sure. Alright, fair enough. Because it's like right near me, I see. Alright, yeah. And that's it. Chat to yours later. Alright, back to study. Wanted to make sure I caught chat. Okay.
Text you do as frequency analysis, it will tell you a number of this. But when you map with monoalphabetic cipher, you know the most occurring alphabet in the cipher text. This must be from E, I can assume. So once you give one, something for E and something for B, and you can actually, using this language statistics, you can actually break this kind of cipher very easily. And in fact, at the moment, probably 20, 30 years ago, we used to give assignments using this, but now there are online web pages where you can break any monoalphabetic cipher. Okay. So this is from the Stallings. The original ideas are developed actually very interesting. The mathematics developed for breaking this kind of classical cipher was all developed by Arabian mathematicians during they were doing trading, right? That time, all these mathematicians they actually built algorithms to break this kind of idea, and these ideas were developed in that. So if you are interested in historical ideas, there are multiple things. And I'm not going to go too much today because I can easily get digressed.
But it was really
we have a lot of things to cover. Okay, so this is about automatic methods and the internet. So this is quite
language frequencies.
So monoalphabetic numbers are safe. What to do? We want to make it much complex. How do you do the complex ciphers? So some idea for one approach for reducing, let's say you want to approach reducing this spikiness of a natural language text, all these kind of things. What do? You introduce something called polyalphabetic cipher. So the question is, how do you make encryption process more complex so that it is difficult to break? Because then the idea is that in a monoalphabetic cipher, the frequency gets revealed pretty easily. So the plain text statistics is visible, and that will help me to find the key. Now, to make it complex, what you do is this process of, let us say A is mapped to T at this point of time. Maybe as time dependent, A gets mapped to something else. So if you somehow introduce time dependent features to your encryption process, maybe the cryptanalysts will find it difficult to do that. So use, what kind of a best idea to use is, use now a set of monoalphabetic ciphers at different time when processing a plain text. So what you do, you got a monoalphabetic cipher 1, 2, 3, 4. Let's say I have a family of monoalphabetic cipher, but I'm going to use it. When I'm going to use it depends on a key. I change a key every time. So this is a simple complex idea. Why I'm telling all this idea is that let's say in the next week I'm going to introduce modern ciphers. We'll come back very quickly, with 1 week. What are the techniques involved in building good cryptographic algorithm? And this is not just about science, it's basically art, and so many other interesting things are there. I mean, so one way of here, do you see the generalization that I'm coming? I'm just making it more complex by just choosing M1, M2, M3, or MT, there are class of things. And I have my key is that at time 1, I pick M1. At time 2, I pick M5.
So what's
At
this
time
called? A
3,
polyalphabetic
so that
cipher?
as time dependent, I pick different monoalphabetic cipher. Obviously, then if a cryptanalyst tries to put a statistics analysis, he will get all A, B, C coming at the same thing, so he will not be able to figure it out the key. Maybe. And it's still a challenge to come up with a very good thing. Remember, there were some of these crime people committing some crimes, and they leave clues to the police. And they, in the past, used some of these kind of ciphers, like ciphered by other cipher, and it was decrypted. It was not possible. And one of our colleague of mine last few you would have seen in the newspapers. He basically he broke some of those. He figured out how he encrypted those things, and it became a big news. But yeah, I'm not going to detail this as well. So what I'm saying is that some of these, which looks so easy, it can have still a practical relevance, or at least of practical interest now. Key could be, so no, at the moment I tell you, the schemes that I'm telling is not used in practice or anything, but what is important is the underlying thinking process that will help us in understanding the modern ciphers. So key could be used to specify which monoalphabetic cipher to use, that I already mentioned. Then textbook has some examples. Please follow them. So that's called a polyalphabetic cipher. Now, one of the simplest example for that is this was introduced by Vigenere. This is called a Vigenere cipher. This is a simple polyalphabetic substitution cipher. Okay, what do you do? Here is a set of Caesar cipher. He takes you got a set of Caesar cipher. The plain text is handled by Caesar cipher with key ki modulo d. So what happens is, I'm going to tell me, because these slides are pretty straightforward, you should be able to understand very easily. So plain text now is put in a sequence. That's how let us say you have an encryptor, you got a plain text coming into this engine, one by one. So we call that as P1, P2 to PD, and every time we take a setup. D could be a very large number.
Okay, hold on. Let me read through this. This is some polyalphabetic substitution cipher. Here a set of Caesar ciphers is employed. So ith plain text symbol is handled by Caesar cipher. With key ki mod d. It is very simple. A key is a multiple letter word. K. I mod d, d being the length of k, I'm guessing.
Number, let's say 5 like that, P1, P2, PD, and then PD plus 1, PD2, PD2. What we do, the encryption process will get is very simple. Take particular sequence of D plain text. So then what you do, each plain text in this PI is PI into K mod 26. So key is basically a sequence of multiple K1 to KD. So in the Caesar cipher, K1 was the key. But here I take a sequence of D digits. So I made a Z monoalphabetic cipher and just simply XOR Ci equal to Pi Ke. And decryption is simply the reverse process. Basically take Ci minus Ka. So D is large, it offers better security. As D increases, you can get a better. Do you get that point?
Sure.
Yeah, this is a very simplest Vigenere cipher is a very popular one.
I think I need to see an example for this one
if you have a
particularly.
Vigenere cipher, how do you do
Oh,
script
it's
analysis?
literally the next slide.
What you do, you will need to somehow, let's say if you just use the plain text statistics, it gets mumbled.
So he actually goes through it
You now
actually.
use every D, every D letter, P1, PD plus 1, P2D plus 1, all of them comes from the same Caesar cipher. So I can run statistics on that and try to look at the common thing. And the moment I determine E of them, then I know one of them and I can slowly do it. So if you know D, this is trivial, but first task for decryption would be first to determine D, and then to find the D, actually there are interesting methods, and a lot of mathematics was invented. This came in about last century. This is due to one miss called Kasiski. If you actually look at some cryptography algorithm, there are a lot of interesting things. Okay, it is enough to understand the complexity how we do that, right? Example of a Wegener cipher here. So, for example, key could be deceptive, and it repeats deceptive in many times. So you can say where we are discovered, like yourself. So then ciphertext is basically W plus D, you get Z, E plus E, you get I, like that. Okay. It's the same Caesar cipher.
D plus W, A, B, C, D, W, X, Y, Z, A, B, C, D, E, E, F, G, H, I. I see.
Thing you can do. This is okay. Then another interesting thing called Hill cipher, which you will probably do with some experiments with the things. So here, I'm actually, so far, what I did. I have a Caesar cipher. Then I started working with D monoalphabetic cipher together. So I made one level of complexity. The next level of complexity that I had made this was Hill cipher. What he does, he actually uses now a matrix. So key is now not just a M vector, it's a matrix. So you can see the keys are elements from the matrices over Z26. So key could be M by M. M could be a number like 10, 10 by 10, except 10 crossed by 10. Process of plain text as a sequence. First process this plain text as a sequence of M symbols. Let P be the plain text block. So you can see every P plain text back. And the ciphertext back is simply obtained by K times P, where K is a key.
Right, hold on. So keys are elements from matrices. Keys are elements from matrices of dimension M over Z26. K is an M by M matrix. So process plaintext as a sequence of M symbols. Okay, let P be a plaintext block. Corresponding ciphertext block is given by C equals KP. What is the decryption function? It's the inverse. Is that meant to be C or P?
Now, what is a decryption function? You apply K inverse times, sorry, this should be a typo here. This should be C.
Yeah, that's what I thought. So this P is a C actually. Just remember that. How do I remember it though? I can't remember it. Just like, actually like somehow modify this PDF. Wonder. Obsidian modify PDF. PDF highlights, sure. Is annotator... It's a sample plugin for Obsidian. Does this mean it's already in Obsidian?
Okay, K inverse times C,
Doesn't
K
matter.
inverse the inverse of K, then you get a you get back in. So moment you have a key is the inverse, like a matrix, then finding attacking this is though not difficult, it is definitely much more complex than the previous simple ciphers. Okay, this you're going to experiment and you will know more about it. So another way to actually make the more complex ciphers out of simple ones are, so this is called a product ciphers. So idea here, why I've got this idea, I've already given you the idea of a transposition cipher, because in the transposition cipher, we don't do anything, so we have a sequence of alphabets. Transposition, for every D block, we put a permutation, every D permutation. And the substitution cipher is simply by changing this either by matrix or a vector, all the things that you use. A product cipher is one, uses substitution and transposition ciphers are not secure. That's what you're vulnerable to cryptanalysis. Then we can think of a more general product cipher by applying several substitution cipher and several transposition cipher sections. So one cipher will apply substitution, and next maybe transposition, next substitution, next transposition. So we will apply multiple rounds of a thing, and leading into some of the techniques that we do it for the modern things. So this is what so these ideas were used by Germans. This is used in German cipher. What was the name of the German cipher used in World War time? Enigma. So this was Enigma during the World War II. Basically what they do, have a rotor machines. So each time you press a key, so the rotor machine will change over. So each set of a rotor machine will have a particular substitution cipher. Basically they use Watsiana cipher, because it's very easy. When A goes to D, D goes to A. So a rotor will simply change all the characters from according to the map, and they are in succession. So as you press key, the rotor things will move, and it will apply a different thing. So this was these ideas were used, and how did Alice break this key? Because that we will come to a very interesting part. That's what we do in this video. This is called plain text, known plain text attack. Because what happened is, when all these machines were there, so in the morning, first you get a hello message, good morning message. So that message was always same, and it was broadcasted. And during that time, the key, you can actually get that one, and you can get the key. So that this was done by the Alan Turing, who invented how to actually break such a thing. So you would have seen the movie by Alan Turing.
Of course.
I'm not going to. Those of you who are interested might go. The marvelous ideas. Sometimes it's not just about breaking. Means not just breaking your head. Just by thinking, you can actually come up with very interesting things. So this is actually, but this idea, substitution and transposition, this idea is is actually lead to modern ciphers. So basically what you do, so this is what, when you really shuffling, when you play cards, what you do? First you do simple shuffling, and then you take two of them and then you put it like this. These are the methods that normal people do, and we do a similar thing with, like all the shuffling things is transposition. Of course, I can't find exactly equivalent to this, but substitution and transposition, these two ideas will come again and again, and we'll use that for modern ciphers. So obviously, from all the mathematics that we have developed using modern 26 thing, we should be able to actually analyze some of these things in detail, and that's what we're going to do in the next week class. Okay. Now that finishes the end of that, and then now I have to go to
Okay.
week 2.
I'm going to pause it there. Alright, so this part is done now. We're going to basically now move on to doing a few, things that I wanted to do. That lecture's taken up some time already. What I really wanted to do was 2 workshops that I don't think I'll do tonight. I have to read a discussion forum, I just said that I would. But 1 lesson from TOP and Leetcode. At least, let me do TOP. And Leetcode, we might do. But let's start with TOP. Alright, let's see. We're going to be doing TOP. We're going to have to close this a little bit. Save the bookmarks. Close tab. And close this. Come on, get up here. Why not? Just do 1. The Odin Project. Let's go, let's do 1. I gotta at least know some stuff. Grid area. And the difference between a track and a line. So a track is just a rail, kind of like 2 lines, and a line is just a line. What is the smallest unit of a grid? It's a cell. What kind of value do we give to the grid column start or grid column end properties? Integers. Okay, I'm gonna call that good. But you know, I have to read some of this. I've pretty much done an example exercise, but I should read this at least. Okay, I'll read through this, just a refresher, but I called that complete. So I said that was good there. I was halfway through reading this a little bit, but probably not too much of a concern. There's JavaScript lesson, advanced CSS and HTML. Wonder what's in here, transitions. Ooh. Web accessibility. Accessible colors, keyboard navigation, meaningful text. Why ARIA? I gotta read up on this, you know. At least the why ARIA stuff as well. Something that I kind of want to read. And you know, there's JavaScript here. A deeper look at Git, working with remotes using Gits in real world. Testing stuff. Yeah, this might be useful. Literally, if I just cut at it every single day, I'll be able to mold something that I like. Quite a lot of the way through. Here's what I'm going to do, right? Alignment of flexboxes. I'm going to mark complete. Alright, and we're just going to say, you know, we're not going to worry about this too much. But a lot of this will be useful to learn, I suppose, just the basics. I'll probably grind through this pretty good as well after I read this, and probably this. Okay. I'll put them in scheduler. Whoops. Alignment. I guess I'll never go on. Continue from this. Right. Just keeping it doesn't hurt. Positioning grid elements as well. React. Yeah. We'll quickly browse through this. Okay. I think we can close this. Alright. Let's look at grid layout using line-based placement. The above examples placement shorthand placement, longhand placement, shorthand placement. So that's the default grid area property. You can define a full area. Counting backwards, sure. And gutters or alleys, what about them? All right, you can add gaps. I mean, that's pretty straightforward, really. WAI ARIA is something that I want to be able to use. The other thing that I need to also make sure of is that I use notes as notes, especially because foundations, I sometimes don't provide enough information. And these things are already fetched as articles, interactive guide to Flexbox, right? So if I searched Flexbox, we have it here. Right, so I'm gonna have to write it here. Flex boxes resource is an interactive guide to Flexbox. Alright, and what is it? This is also good, except I don't have a direct link, right? Also saved it. No, I didn't. I didn't save it. I should save it. Now I'll just link it. I'll link it directly into here. Right? And this is something else that I wanted to read, but I never got to read it. Except I feel like I would know enough about it now to not even worry. But let's just close it up. You know, we'll close this up. And we can close up alignment. Keep WAI ARIA. We'll keep foundations as the top here. Yeah. Don't know if this really is necessary. I wanted to read this, so this was the yep. And I'm gonna say, you know, typical use cases for flex boxes. Let's have a look at this. Space between items, split navigation, create item, card layout footed down, media objects, flipping the media object, form controls. Yeah, okay, well, those all seem fine. The CSS trick box, just CSS tricks, guide to Flexbox. Oh yeah, so this is a good resource that at the end of the day I want to also have this available. So, oops. Alright, what else? So that's fine. I'll then basically say, you know, all of this I'll just ditch, basically. Because I think it's going to hold me back a bit. If I actually just do this all. So, pull it back a bit. And this is the main part really, you know. Add task button. You know, we're almost through into implement creating a task. We just need to add task button. And maybe invoke a new task modal below a highlighted task, which by the way, highlighting a task is another situation that I need to think of in general. Edit task button on right side of task item. That's also something I might want to think of, but could come later down the line. Just essentially don't need to edit your task, right? But I mean, this is also pretty easy to fix, to do. Consider any shortcuts we can implement. That is keyboard shortcuts, but I should make that clear. But no, there isn't. And make task list functional, whereby you can CRUD tasks into the back end. So this is at the end, basically. Only thing left would be the deletion, which could be done with the edit modal or edit task button when we get there. But you want to basically be able to CRUD everything by the end of it. Okay. And with all that, I wanted to research one other thing, which was linear. I'm gonna have to change the title of this stream to basically being no Leetcode today. So yeah, the Odin Project. Yes, study. Yes, scheduler development. But no Leetcode for today. Okay, so Linear is the app that I was thinking of trying out. Linear, a purposeful built tool for planning and building products. Meet the system for modern software development, streamline issues, projects, and product roadmaps. I mean, it does look pretty cool, doesn't it? Powered by the world's best product teams, sure. Raycast, Netlify, Supercell, nah man. Fuck Supercell. Made for modern product teams, Linear shaped by the practices and principles that design world-class product teams from the rest. Relentless focus, fast execution, and a commitment to the quality of craft. Purpose-built for product development, designed to move fast, and crafted to perfection, sure. It is built of high performance with its keyboard-first design, real-time sync, and zero-friction workflows. It delivers a focused experience, ideal for fast-paced in development environments. Crafted to perfection. Prototype beta, something. sure issue tracking you'll enjoy using. Cycles, linear insights, iOS and Android app, an API built on strong foundations. Pricing, what's that like? So free for everyone. I want to see linear. Is there a linear GitHub? There is. Tools, SDKs, and plugins for linear. So it's not even linear. Are you telling me that linear doesn't have it's not open source? I don't think it is. Unlimited members, 2 teams, 250 issues, plus unlimited archived, Slack, GitHub, and API access. To be honest, not something I really like because there's paywalls. Literally the only reason why I won't use something is because it's paywalled. And I'm not going to be the one to be a hypocrite because I'm going to make something that's not paywalled at all. We'll see how it goes though. Maybe I'll finally come around to paywalled stuff. But yeah, I don't like having dependence on tools like this. So it's not something I'll probably use ever. $12 per user per month. God, imagine 100 people, $120 per month. Not even gonna bother. It's not happening. Okay. We can close this. Okay, let's have a look at WAI ARIA. In the previous lessons, you learned several ways to make websites more accessible. Those lessons, however, were just the tip of the accessible iceberg. Why ARIA introduces attributes that can help make websites even more accessible by modifying the semantics and context of elements, which can give you greater control It's very noisy, isn't it? I think it is. I hope it doesn't affect anyone too hardly. Alright, but let's continue. Which can give you greater control over how those elements are perceived by assistive technologies. Sorry, let me reread that. So, why ARIA introduces attributes that can help make websites even more accessible by modifying the semantics and context of elements, which can give you greater control over how those elements are perceived by assistive technologies. Because this subject can get so complicated, we're only going to cover 2 attributes that can get you a lot of use from. You will know the purpose of why aria, know what aria can't do, understand the 5 rules of aria use, understand what the accessibility tree is, understand the 3 aria attributes that can add elements, that can add labels to elements, understand what the aria hidden attribute does. Why did you break your keyboard? Yeah. What can I say? I know. But if you're interested, you know, like... Okay, what is Y aria? It stands for deep breadth. Deep breadth. The Web Accessibility Initiative What? The Web Accessibility Initiative's Accessible Rich Internet Applications Specification. Damn. That's good. The purpose of... I feel like I'm pronouncing this wrong every time, but Y aria. The purpose of Y aria, often referred to as just aria, is to define a way to make web content more accessible when native HTML is unable to do so. Sure. Think of aria as something that fills in the accessible gaps left by native HTML. It's important to note that aria can only modify the semantics or contexts of an element. Aria can't modify an element's appearance, modify an element's behavior, add focusability, or add keyboard event handling. 4 things that I haven't really learnt about, and I feel like I would be missing context if I don't fully understand these terms. So modify an element's appearance. Sure. Modify an element's behavior. Sure. Add focusability. Sure. But add keyboard event handling, I'm guessing like these are like keyboard shortcuts right here. Okay, so it's important to note that aria can only modify the semantics or context of an element, just like semantic HTML, right? So when you use aria, you will usually have to take additional steps to add in any missing semantics or functionality. Remember the keyboard navigation lesson and how we had to add functionality to div buttons? Right. When you use aria, you will usually have to take additional steps to add in any missing semantics or functionality. So you will have to do this yourself, basically. Yeah, well, here's the thing. I don't remember because I haven't really done this yet. Okay, the 5 rules of aria. Oh wow. Oh wow. Do I feel like I'm reaching too far? Maybe. Let's just have a quick breeze over this, and then we'll come back to it. But the 5 rules of aria. Aria can be extremely powerful when used correctly, but it can be equally as dangerous when used incorrectly. Because of this, you should keep in mind that no aria is better than bad aria. Even when you have the best intentions, the WCAG has something called the 5 rules of aria, which, as you may have guessed, are rules you should follow when using aria. Although we don't cover all of the terms mentioned below, it's still important to understand the rules themselves, especially if you decide to dive deeper into aria on your own. Always use native HTML elements and attributes over aria where possible. Never change native semantics unless you have no other choice. All interactive aria controls must be usable with a keyboard. Wow. Never use role presentation or aria hidden equals true on focusable elements. And all interactive elements must have an accessible name. Damn. Have an accessible name. Now this last one, I feel like I've seen. What do I mean? Well, let me go to my project. Ah, KFC, hello man. Thanks for joining again. Okay, display name, button. All interactive elements must have an accessible name. So I'm guessing, you know, display name of button is what this is doing. Making it accessible. Okay. My assumptions are there. That's what I'm guessing. The accessibility tree, before we get into a couple of the ARIA attributes available to us, it is important to know some basics of what the accessibility tree is, as it will help you understand just what those attributes are actually doing. The accessibility tree is based on the DOM, something you should be very familiar with by now. While the DOM represents nodes and objects that makes up a web page, with the accessibility tree contains only accessibility related information that will be used to assistive technologies. The way ARIA works is by modifying the properties of the objects that make up this accessibility tree. For this lesson, we'll only go to focus on two of these properties. Name. Accessible, known as the accessible name, this is what assistive technologies announce to your user, and what separates elements of the same type from one another. The name that may be set by one or more native elements, including the text content of the element. The label element, or the alt attributes to name a few. Okay, this is what assistive technologies announce in addition to the accessible name. The thing is, I never in my life would ever even think about this. This is like something that you find further down, way further down in your development. So what I'll say to that is, you know, keep it tabbed in my mind. Oh, keyboard navigation. Shit. I really want to read that. Let me think about it for a second. Okay. Alright. Yeah, I think, you know, it's still a matter of understanding and learning the right things first. I agree. But it gives me an idea of what I'm looking at. So I'm not mad. I'm not sad. You know, I've gone quite far as well. I'm definitely happy with my progress. To make myself even happier, I will. Alright. Yeah, I won't. This is a lot. Okay, I'm gonna call it a night for tonight. It's been fun. It's been good. There's been quite a bit of study and learning. But tomorrow I'll be at uni, so there won't be much alive for a stream, but you bet I'll be learning stuff. So continue learning, everybody. We'll get there by the end of the day. And if we don't get there, we'll still have learnt a lot. Alright. Thanks for watching, guys. Appreciate you sticking along for so long. For the 4 or so people in the stream right now. Appreciate you all, and I'll catch you guys later. See you, KFC. Bye.